Welcome back, everyone. We're just going to continue on with our lessons about the metric system and the standard system. And last time we talked about the metric prefixes and how that you can actually figure on those, how you can convert from one to the other with the prefixes. Now we're going to talk about pressures and a few things. Pressure, we'll talk about forces, but this simple diagram I've got in front of you, this free body diagram, we're looking at just a beam and we're exerting a force in the y-axis. Now the force that's being placed on it is causing the fibers inside of the material of that beam to go through a process called deformation, and that's when stress is being applied throughout this beam. Okay, we have these stressors, and that force provides that stress, which is pressure. All right, so we're going to have pressure now from the force. Now, one thing we got to understand: pressure is equal to the force divided by the area. That's how you find pressure. So it's determined on the area of the cross section of the member and how much force you're applying on it. Okay, that's how we get our pressure. So the force up here that's being applied to this beam, in the standard side of things, this would be the pounds. Okay? That'd be pounds. And in the standard unit of measurement, pressure is typically going to be pounds over the area, which is typically square inches. Okay? So that's typically what we're looking at. Well, on the other hand, metric system, the force that's applied on the metric system, it is called a Newton. Okay? So when you use the same formula, this is standard, this is metric. Over here, again, pressure equals force over area. So when we start to do this, the force in the metric system is a Newton divided by meter squared. And always remember that 1 Newton per meter square equals a Pascal. Okay? That's something to remember. So, again, the force that's being applied to an object is going to be in either pounds. You're going to see it in pounds. In the metric side, you're going to see it in newtons. Okay? So, when you look at pressure, the pressure that and the stresses that cause the pressure in the members that it's putting the force onto, the pressure is going to be in pounds per square inch on the standard side. In the metric side, it'll be newtons per meter squared. So we've got to be able to convert back and forth between the two different units. Let's show you how to do that. Okay? So, remember, and I want to put a couple conversion factors on here. And it's very easy to remember. 1 inch equals 25.4 millimeters. I'm sure you've seen that in some of my classes before. Or you can say 1 millimeter is equal to 0.03937 inches. Okay? So when you're thinking about these things, And let's say, for instance, in this little design here, I have a part that I'm working on that's 10 inches, and I want to convert it to millimeters. This is all you have to do. You use one of these formulas here. And what I do is I put my 10 over 1, and I come over here, and this is where I put my conversion factor. Put 10 over 1 over here. Make sure you put your units up here with this. And now what I want to do is both of these will work because they both have the unit I have, inches, and they both have millimeters, is exactly what I need as well. So always remember when you're doing this, completely opposite of the unit that you have is where you want to put this into it, this equation. Like when you're looking at this conversion factor, the 1 inch would go down here because you want those units across from each other so that you can cancel them out. And then what's left over, because we're using this one right here at the top, what's left over you put it on the other side of it, 25.4 millimeters. Now the units are canceled out, and what's left is 10 and 25.4. So what you do is just 10 times 25.4, and then you put that in here, and again that would be 254, and then 1 times 1 is 1, and don't forget that millimeter comes over as well. So 10 inches is also equivalent to 254 millimeters. Okay, so let's do another one. Now let's get into the pascals and the pressures. And you've seen that so far. We've been looking at yield strength and ultimate strength, and you've been seeing those numbers, and you're probably like, well, how do I convert back and forth? Well, this is how we do it. Always remember that 1 pound is equal to 4.4482. The number goes on a little bit further than that. Okay? And 1 Newton, and I'll write it out, 1 Newton is equal to 0.2248. Okay? And that's 0.2248 pounds. Okay? And this one up here would be Newton. Forgot to add those in. So it looks like that. So 1 pound is equal to 4.4482 newtons, and 1 newton is equal to 0.2248 pounds. So when I'm looking at that, and let's say for instance I have 100 pounds. I have 100 pounds, and I'm wanting to convert that into a newton. I can use either one of these formulas. It doesn't matter. And what I do, I take my 100, put it over 1, and then again, this 100 would be my pounds. Well, I have to use one of these conversion factors that has both pounds and newtons. Well, both of them has pounds and newtons in it, right? So all I have to do is I'll choose one. I'll choose this one down here. It doesn't matter. And you all see that my pounds would have to go opposite of it so I can cancel them out. So what would be left would be newtons. So it would be 0.2248 pounds. I get to cross those out. And the only thing that's left, and I have to use the whole formula, the whole conversion factor, what's left after I got this one? The newton. It goes right up here, whatever's left over. There's my newton. So it would equal 100 times 1 is 100. Divide it by 1 times 0.22, so it'll be 0.2248, and that newton comes over there. And then we'll grab us a calculator. Very simply, 100 divided by 0.2248 equals 444.84 be fine. We'll just round up, and that's newtons. So 100 pounds is equal to 444.84 newtons.